Top front end will show us three two-dimensional views of a three-dimensional object. Our three-dimensional object will be represented within a grid. Always on the top left-hand side, we have our top view. On the bottom left-hand side, we have our front view. And on the right bottom side, we have our end view. This diagram represents the three different viewpoints on our 3D object. Top view looks from the top down, front view looks from the front back, and the end view will look from the right-hand side looking left laterally. This is very important as many students confuse which direction the end view comes from. The end view has yourself oriented on the right-hand side looking laterally to the left. Manipulating our three-dimensional object, we can see what we were referring to. Our top view will be from the top of the object looking down. Our front view will be from the front of the object looking back, whereas our end view will be from the right-hand side of the object looking laterally to the left. Top front end requires accountability. Any changes that we have in our three-dimensional object needs to be accounted for in our two-dimensional viewpoints. We talked about how our top view of this object will require us looking at the object from the top looking down. Notice that we have these solid lines here. These solid lines in top front end indicate to us that there is some change in geometry within our three-dimensional object. Sure enough, these solid lines here, 1 and 2, represent the changes in plane from stair 1 to stair 2 and stair 2 to stair 3. This line right here, we can see becomes this line over here. In this line right here, which indicates the change in elevation from stair 2 to stair 3, becomes this line right here. Likewise, we can do the same for our front view. This would be the front view of our object because we look at our three-dimensional object from the front looking towards the back. Note that this shows the outline of our 3D object. Finally, if we think about our end view, which is coming from the right-hand side of our object, looking to the left, so we'll rotate our object around. Each of these changes, each of these lines indicates some change in geometry. This line indicates the change in elevation from this plane to this plane. This line right here. This line indicates the change in elevation from this plane to this plane. This line right here. In an actual top front end question, we would be provided two of these views of the object. One of the viewpoints would be missing, and we have to, based on the two views we've been provided, determine what the proper end view or front view or top view of that object will be based on the other two viewpoints. On the right-hand side, we have a completely filled out top, front, end grid. Remember on test day, you'd only be provided with two of these viewpoints and missing one viewpoint. You'd have to determine what that missing viewpoint was. But for educational purposes, we filled out the entire grid and also included the three-dimensional object. Note how each of these viewpoints represents either the top view, the front view, or the right hand looking to the left view, or also known as end view of this 3D object. All geometry has been accounted for. Because we can see everything directly, I can see this stair. If I'm looking from the top view, I can see this stair changing to this stair, changing to this stair. Those are direct changes I can see. We have representation of these changes in geometry with a solid line. Likewise, from the end view, if I look from the right-hand side, looking to the left, I'll be able to see this plane, I'll be able to see this plane, and I'll be able to see this plane directly. And so these lines here and here represent the changes in plane that I'll be able to see directly here as well as here. Let's now look at the exact same object, but rotate it 180 degrees and consider it a new question. Note that this is the exact same shape, in all ways same dimensions, the only difference being that this object has been rotated 180 degrees. So now let's consider the top, the front, and the end view. The top view would look like this. Again, we're going to have lines here and here to represent the changes in geometry from here to here, represented by this line, and from here to here, represented by this line. Let's look at the front view. Now note how the front view is a flipped mirror image of object 1. Where we're going to differ is in our end view. Again, our end view being from the right-hand side of the object, looking to the left. In our end view, all we're going to be able to see directly is this big white wall, right? This big white wall right here. As we talked about before, top front end requires accountability. Every single change in geometry does need to be accounted for. And so the way that top front end will deal with this is by using dotted or dashed lines. Dashed lines must be used to indicate to us that there is a change in geometry occurring, although we can't see it because of this big white wall. So again, the end view looks from the right-hand side, looking to the left. And if we rotate our object to that view, this is all we're going to see. But top front end will allow us to see this by giving dashed lines. This dashed line represents this change in geometry from this plane going up to this plane, and this dashed line represents this change in geometry right at this point. And right at this point, we have a change in geometry which is shown to us in our end view through these dashed lines. Let's quickly look at our new grid, top front end grid for this three-dimensional object. And you'll start to notice as you do top front end that there has to be perfect, because of the accountability, everything has to perfectly line up. So you'll notice that the top view, this line right here, marks exactly with this change in elevation in our front view. And likewise, for this line right here, marks exactly with this change in elevation in our top view. And now if we go ahead and look at our end view, we have those dotted lines because, as we talked about, looking at the end view from the right-hand side, looking to the left, all you're going to see is this big white square. But because top front end has to have accountability, they have to let us know somehow that there's a change in elevation here and a change in elevation here. And they do that with dotted lines. So a dashed line here and a dashed line here lets us know. And again, because of perfect accountability, you'll see that these lines line up exactly. So this change in elevation marks exactly with this dashed line, and this change in elevation marks exactly with this dashed line. So we can see now that we understand the difference between solid lines and dotted lines and how everything in top front end needs to be accounted for. Now let's take a look at a question. This is an example of what a top front end question would actually look like. We are provided with two views, in this case the top view and the end view, and we're asked to determine what the front view would be. We won't actually solve this question now, we'll save that for when we discuss strategy. This is the front view of two different objects. Now imagine you had a top front end question where the top view and the end view of the objects were presented, but the front view wasn't, and you had to guess what the front view was. Well, look at the top view for these two objects. I've staggered the two objects just so that we can see all top, front, and end views at the same time. So note how the top view is the exact same. In both we have some sort of change in plane here and here, and we have a change in plane here and here, or change in geometry. And that is in fact what we have in both objects. So if we, based on the top view, we couldn't tell the difference between these two objects. Now what happens if we had the end view of these two objects? Well, think about what the end view is going to look like. In both, you have a solid white wall in this location, and so we're going to have to use dotted lines on that white wall to represent any hidden geometry. Well, there's going to be a hidden geometry in this object along this line and along this line. And we see that represented here by dotted lines. This for the line that goes along there, and this for the line that is going to go along here. Same for our object over here, which we've discussed before. We can see that we're going to have a dotted line here and here to represent this change in plane from here up to here. along this line, and the change in plane from here up to here along this line. So note that the top view is the same for both objects, the end view is the same for both objects. It's important to note that both of these front views could not be given as answer choice options for this object. As we've seen, the top and the end view will correspond with both of these front views. If this question was given, one of these answer choices would have to differ in some way so that it did not correspond with both the top and the end view, therefore allowing you to eliminate. Just a quick note about ramps in top front end. When we see a solid line in a two-dimensional viewpoint, all it tells us is that there has been some sort of change in geometry, but we don't know anything about what that object is going to look like. We know there's a change in geometry at this location and at this location, but we don't know whether this is a column that is higher than these two columns, or if this column is taller than both of these columns, or this column is lower than both of these columns. And we also don't know that whether this object in here, this face, is a flat plane or a ramp. So notice that the top view of all three of these objects look the exact same. But if we go ahead and look at what these objects actually look like, they're all very different. It could be a flat plane, could be a ramp in this direction, and it could also be a ramp in this direction. All we need to know, though, is that some sort of change in geometry is being located wherever we're having these solid lines. A few years ago, you used to be able to use a method called line counting on the DAT, which is where you would just count the number of lines in one of your viewpoints from left to right and count to see if the other view had the same number of lines from whatever perspective you originally counted. That method doesn't really work on the DAT anymore. The DAT administrators have wised up to it and have created more challenging tests to combat this method. However, at DATgenius, we use our feature matching technique to still answer almost all of these questions. Feature matching is a very, very quick strategy. So the idea behind feature matching is we can look at many different features in isolation, one at a time, and look at our different answer choices. So if that feature that we picked in one of our viewpoints exists in the answer choice, then you cannot eliminate your answer choice. But if that feature doesn't exist in the answer choice, then you can cross it out. Feature matching is really quick because we're only looking at one feature at a time. So you'll look at, say, for example, this feature, and then quickly go through your different answer choices. That one feature that we looked at, it may eliminate one answer choice, it may eliminate two answer choices, it could even eliminate three answer choices, it may eliminate no answer choices. The idea is that it doesn't matter because it's so fast. Once you've looked at that feature and all of your answer choices, pick a different feature and use that specific feature now to look through the different answer choices. We're keeping things super simple for ourselves. We're looking at a feature in one viewpoint and just seeing if it exists in those different answer choices or not. Using simple features, you can solve a top front end question in all of 30 to 35 seconds and make them super, super simple and use one viewpoint, one view option to eliminate down to our answer choice. Or use two view options, but in isolation, not have to figure out how they work together. So let's do that quickly now. I'll just take a quick glance at my answer choices and realize that very obviously they differ on the top. So I'm going to know that this feature here, this line in the top view, means that there has to be something going on this portion of our front view. And the fact that I see that this is a solid line tells me that I should be able to see it directly at the top of my front view. So this feature here, it's on the right-hand side of the top view. I see it here in A, so I can't eliminate A. I don't see it in B. There's nothing that goes on this part of B. My top view tells me that right in this location, I have a change going on. And because the front view shows the same object as the top view, I have to have something going on in this area of the top view. And because this is a solid line, I know it must be at least extending up to the top of the front view. I don't have that in B, so let's eliminate B. I do have it in C, and I do have it in D. So we took a little bit more time there because I'm explaining things, but looking at this one feature, I would say yes, no, eliminate, yes, yes. That took 4 seconds. Now let's move on to a different feature. We could look at this line over here in the top view, but a quick examination is going to show us that we have it in all of our answer choices. And note that yes, this right here would cause a solid line in the top view because this is a change in plane. And as we talked about before, a ramp is still a change in geometry. So this right here would cause a feature. So because this won't help us out, let's go and look at our end view. We know that the end view and the front view are in the same plane. So I should have some feature in my front view right around here and right around here. And I know that I won't be able to see it directly from my end view, so it can't extend all the way to the right-hand side of my front view. Because if it did extend all the way to the very far right-hand side of my front view, then I would have solid lines visible in the end view. So therefore, I should have two hidden features here and here. Well, I will have a feature here and here, which would be this location, if we were to move this object into its proper front view in the grid. However, if I think about my end view on my front view, I'll be able to see this feature directly and this feature directly, because there's nothing blocking them. Therefore, those would have shown up in my end view as solid lines, here and here. But I can see that I have dotted lines here and here. Therefore, I can eliminate A. Moving on to B, I see that this will cause a dotted line in this location, corresponding to here, and this will cause a dotted line in this location, which corresponds to here. These will be hidden if I think about my end view on my front view. My end view on my front view, I won't be able to see these features directly. I'll only be able to see them indicated as dotted lines on my end view, which is what I have, so we can't eliminate C. And we can see D is missing a feature in approximately this location, which we have here in our end view. Therefore, we can eliminate D. C is our answer.